Hi there. Welcome back to another Firecast for Cloud Functions. My name is Jen Person, and last time we saw how a promise object was used to tell Cloud Functions to wait for a database sprite to complete before cleaning up. The promise object came from the real-time database API. For that function, I didn't have to do anything with the promise other than return it from the function. There's a lot more to promises than that. If you're going to be writing code with Cloud Functions, you'll definitely need to know how to work with them. So, I'll unpack some of those details for you today. A promise represents some asynchronous work that should eventually complete. If you're an Android developer, this is very similar to the task object that you use sometimes with the Firebase Android SDKs. When the work tracked by a promise is still executing, the promise is in a pending state. Then, if the work completes successfully, the promise is said to be fulfilled. Or, if there's an error, the promise becomes rejected. These are the only three states that a promise can be in: pending, fulfilled, or rejected. And once a promise becomes fulfilled or rejected, it can never change state again. Now, let's go back to that code from the last video. I returned the promise coming from the database reference set method. When you return a promise like this, Cloud Functions will wait until the promise becomes fulfilled or rejected before moving on and cleaning up that function. This is fine. However, sometimes you might want to trigger more code to execute after a promise is fulfilled. You can do that with the then method on the promise object. Let's see an example of how that can be useful. Imagine you're beginning to write a function that emails an employee's expense report to their manager when it changes. Here, we have a database trigger with wildcards for any employee ID and report ID nested inside. I can get the employee ID from the event params, the string containing the report from the event data, and a reference to the root of the database to use later. I need to code up a few things in this function to make it work. The plan here is to first read the manager's employee ID. Then, I'll use that ID to look up the email address of the manager. And finally, I need to send the report to that email address. I can find the employee ID by building a reference to the node where the employee's data is stored, and looking at the manager field under that. Note that ECMAScript 6, which is the flavor of JavaScript supported by Node, gives me a neat way to insert a variable into a string by using backticks as the string delimiter. Now, I'll use the method once on the database reference to read the data in that field. Once returns a promise that becomes fulfilled when the data is available. To get the snapshot with the manager ID, I'll use the then method on that promise to trigger some code when it becomes available. A couple things to note here. Then takes a JavaScript function that itself takes one argument. What you see here is the ECMAScript 6 syntax for writing an anonymous function. Here, snap is the argument to that function, and that fat arrow introduces the function body in curly braces. Now, I'll get the manager's ID from the snapshot, which I can use to find their email address stored in their own employee record. So, I'll build a reference to that and use once again to read the data. There's one more important thing to know about that function passed to the then method. If you return another promise from there, when that promise gets fulfilled, it will also fulfill the promise returned from then. So, when once finishes loading the email address, I can arrange to do more work after that using the promise returned from then. At this point, I have the manager's email address and the report from the original event. And now it's time to send the email. Let's imagine I already have another JavaScript function that will do that, and it returns yet another promise that becomes fulfilled when the email is queued for delivery. I can return that final promise from the function to tell Cloud Functions it can terminate and clean up after the email is queued. And that's pretty much all we need to make this function work. But actually, I can shorten this code up a bit. It's common to chain all the promises together to make this code easier to read and write, so I'll tidy up this function right now. That looks better, don't you think? Reading this function out loud, you can say, first, use the employee ID to find their manager's employee ID. Then, use the manager's ID to look up their email address. Then, send the report to that email address. And that exactly matches the three steps that I stated earlier. But what happens if something goes wrong during any of those steps? You can handle that case with the catch method on a promise. You pass it a function, and it will be called if any promise in the chain is rejected. So, I'll add a catch to my code. I'll pass it an anonymous function that will be called with one parameter, which represents the reason for the rejection. That object probably contains some error, and you'll have to check the documentation for the method that gives you the promise in order to know how to use it. Here, I'll just log it. Catch also returns a rejected promise, so I don't have to do anything else here because I'm already returning that from this function with the return statement at the top of this chain. Alright, as you can see, chaining then methods with promises is a pretty handy way of sequencing bits of work that depend on each other's output. But what if you have some items of work that don't depend on each other and could execute concurrently, working all at the same time? You can handle that with promises as well. Let's take a look at another situation. Let's say I'm writing a function to send two employees an email when one wishes to thank the other. I already have their employee IDs ready to use from path wildcards. I can look up their employee records independently of each other with two separate queries. Now, I have two promises that will each become resolved when the records are available. With these promises ready, I can pass them in an array to the function promise.all. This function returns yet another promise, which is fulfilled only after all the promises in the array become fulfilled. So I'll use its then method to keep doing more work. The result object that comes from this promise is an array of fulfilled results that each correspond to the promises in the array. I can index into that array to find the snapshots provided by each promise. Now, I can reach into those employee records to get the names and email addresses to use for composing the emails. It's great to recognize the efforts of your employees. If send email also returns a promise, we can use those to wait for both emails to be queued using promise.all again. And to finish this function properly, I should return the promise that comes from the first promise.all. This will make my function wait until all the work is fully complete before cleaning up. Now you know a lot about promises. You will use them frequently with Cloud Functions. In fact, every function you write should return a promise if it has to wait on work to be done, and they almost all will be doing exactly that. The only exception is HTTP functions, which do not return promises. For that type of function, you have to send a result to the client, and I'll cover that in another video. But for today, be sure to keep your promises when working with Cloud Functions, and I'll see you here next time on the Firebase YouTube channel.